Hi, this is Coach Dorf. We're now going to look at a problem from section 4.9. And in this problem, we have an object that's dropped from the top of a building that's 100 meters above the ground. And we're supposed to find various information related to the questions they ask us. These are given in parts A, B, C, and D, and we're going to do each part one at a time. So we'll start off with part A. So the first thing to notice is there's really not a lot of information given here. And you might think, how can I find an equation? They don't give me an equation or a function to solve this. Well, the key idea here is to note that gravity is 99.8 meters per second squared. And we're using, our units are meters, so we're going to use 9.8 meters per second squared. That's going to help us figure this out. Also, I'm going to use the fact that we have three types of equations. We have, so this is distance above the ground, or height, if you want to think about that. V of t is velocity of the object, and a is acceleration. And we know from before that the derivative of s equals a velocity, and the derivative of velocity equals acceleration. So we're going to use those ideas here. I know that what is the initial velocity? How fast is the object traveling before I drop it? Well, it's 0. That's the initial velocity. So I haven't dropped it yet. Also, what's the initial height? Before I drop the object, how far is it above the ground? It's 100 meters. So that's the initial height or distance above the ground. And we're going to use gravity is 9.8 meters per second squared. We're going to use that to start finding our equation. And that's going to give us the fact that the acceleration is going to equal negative 9.8 because it's going downwards, so it would be negative. And now we're going to use the fact that the derivative of the velocity equals the acceleration. So we want to find s of t. We know that the derivative of the velocity equals the acceleration. So if I want the antiderivative of a of t, right? That's why we're doing this problem in this section, because we want to find, we're going to use antiderivatives. So v of t then is going to equal the antiderivative of a. And so the antiderivative, a is negative 9.8, so its antiderivative is negative 9.8 t plus a constant. Since the initial velocity was 0, now if we plug that into v of t, we get 0 equals v of 0, which would equal 9.8 times 0 plus c, and that's just going to give me c equals 0. So my general equation for velocity in this case is 9.8 t plus 0. So we have this. All right, now we want to find s of t. So we're going to use the same idea that the derivative of s of t equals the velocity. So we want the antiderivative of v of t. Again, that's why we're doing this type of problem in this section. S of t is going to be the antiderivative of v. So v was 9.8 t. So that's going to give me negative 9.8 t squared divided by 2 plus, I had 0 there, so I don't need to add anything there, but I have to add another constant. Now I could put a c here, but we already used c, so we're going to use a different variable. We're going to use d. All right, so that turns out to be negative 4.9 t squared plus d. And then we're going to use the initial condition that s of 0 was 100. And so we have 100 equals s of 0, which is negative 4.9, 0 squared plus d. And that gives me then d equals 100. So my s of t is negative 4.9 t squared plus 100. And that's what we needed to find in part A. Part B. So let's go back here to part B and read what it says. It says, how long does it take for the object to reach the ground? Now that we have an equation here, we can use this information. So the object reaches the ground when s of t is 0, when the height above the ground is 0. We have negative 4.9 t squared plus 100 equals 0. So now I'm going to solve for t. So that gives me 4.9 t squared, or t squared equals 100 over 4.9, which then gives me t equals plus or minus the square root of 100 over 4.9. T is time. We're not going back in time, although it'd be really cool if we could. we're going to just go forward in time, so we want a positive value. So we're going to have t equals positive square root of 100 over 4.9, which is approximately equal to 4.516 seconds. And that's the answer to part B. So let's go on to part C. Go back up here again. Part C says, with what velocity does the object hit the ground? All right, so what does this mean? Well, it hits the ground with a velocity of v, this value that we got, v of t, where t is coming from the result we had from the previous part, that comes from here. We just want to evaluate v at that part, so at that value for t. So we have 9.8 times the square root of 100 over 4.98. And if I put that into a calculator, I get approximately negative 44.27 meters per second. Okay, now on to part D, the last part. If the object is thrown downward with a speed of 1 meter per second, how long does it take to reach the ground? So, okay, in this case, we have the problem's a little bit different now. We still have that a of t equals negative 9.8. When I take the antiderivative of that, so I get the antiderivative of a, which would be v of t, the antiderivative would be negative 9.8 plus c, all right? But I don't have that the initial velocity is 0. This part, v of 0 equals negative 1 instead of v of 0 equaling 0 as in part A. So that changes things. And so now I'm going to use this, though. I'm going to have negative 1 equals v of 0 equals negative 9.8 of 0 plus c. And that means c is going to equal negative 1 in this problem. So now I have, this gives me that v of t is negative 9.8 t minus 1. Now we need to find s of t. All right, and we're going to do it the same way as we did before. We're going to take the antiderivative of v. So s of t is going to equal the antiderivative of v. So that's going to be negative 4.9 t squared minus t, because I had that negative 1 here. And when I take the antiderivative of negative 1, I'm going to get negative t plus the constant d. And we know that since s of 0 is 100, that doesn't change. All right, we didn't climb up farther. We didn't go down in the building. We're still at the top of the building at 100 meters. Still at 100 meters. When I plug that in there, we get that 100 equals s of 0, which is going to equal d. So d equals 100. So s of t is going to equal negative 4.9 t squared minus t plus 100. Now, are we done? Well, no, because the question said finally to find how long the object takes to hit the ground. So the last step, to find how long the object takes to hit the ground, we solve s of t equaling 0. So now we have negative 4.9 t squared minus t plus 100 equals 0. How do I solve that equation? I use quadratic formula. So we use the quadratic formula. So I've got t equals negative b. So negative b, it's going to be negative 1 here, plus or minus the square root of b squared, negative 1 squared, minus 4 times a, which is negative 4.9, times c all over 2 times negative a, which is negative 4.9. When I do that, I get 1 plus or minus the square root of 1,961 over negative 9.8. And so then t is approximately equal to 5.519 and negative 3.519. We're not dealing with negative time, so we're going to leave off this last answer. We just end up with t equal to 1 minus square root of 1961 over negative 9.8. That's the one that gave us the positive t value, which is approximately equal to 5.519. I hope that helps.